for today's video, we're going to talk about video tutorial on application of integral in computing the volume of solid of revolution. It is presented by the Group 1 members Aaron J. Cecil, John Henry Nakay, and Mary Jane C. Smart. So first, let's talk about solid of revolution. In geometry, a solid of revolution is a solid figure obtained by rotating a plane curve around some straight line, which is the axis of revolution that lies on the same plane. The surface created by this revolution in which bounds the solid is called the surface of revolution. Volume of solid of revolution. You can also use the definite integral to find the volume of solid that is obtained by revolving a plane region about a horizontal or vertical line that does not pass through the plane. This type of solid will be made up of one of the three types of elements, which is the disk, washers, or cylindrical shells, which is each of which requires a different approach in setting up the definite integral to determine its volume. In short, the volume of solid of revolution contains three methods in solving the volume of the solid of revolution. So first, disk method. Disk method is used when the axis of revolution is the boundary of the plane region and the cross section are taken perpendicular to the axis of revolution. Then you use the disk method to find the volume of the solid. Because the cross section of the disk is a circle, which is the area is pi times r squared, then the volume of each disk is its area times its thickness. If a disk is perpendicular to the axis, then its radius should be expressed as a function of x. If a disk is perpendicular to the y-axis, then its radius should be expressed as a function of y. So there are two formula in solving in using the disk method. The volume of the solid generated by revolving the region bounded by y equals to f of x, or function of x, and the x-axis on the interval AB about the axis is, the formula is equals to volume equals to integral a to b pi times f of x squared dx, while the region bounded by the x equals to f of y and the y-axis on AB, a and b is revolved about the y-axis, then its volume is equals to integral a to b pi times f of y squared dy. Note that f of x and f of y represent the radii of the disk, or the distance between a point on the curve to the axis of revolution. So, example of using the disk method. Example number 1. Find the volume of the solid generated by revolving the region bounded by y equals to x squared plus 2 and the x-axis on -3 and 2 about the x-axis.
So the next problem is, find the volume of the solid generated by revolving region bounded by y is equals to x squared plus 2 and the x-axis -3 and 2 about the x-axis. So in this problem, we will be using the disk method. So the first thing that we will do is to make a graph, and as you can see, I already made one and I came up with this kind of graph. Just recall on graphing quadratic equations to know how did I came up with this graph. So let us now solve for the volume of this one. So we have here y is equals to x squared plus 2 and bounded by x is equals to -3 and x is equals to +2. So the formula that we will be using is this one. B is equals to pi A to be y squared dx, since it is said here that the axis of rotation is in the x-axis. So we will now substitute all the values that we have. So v is to pi. We are given limits here. That's from negative 3 to positive 2. So 3 to positive 2. And our y is x squared plus 2 squared dx. So we will be performing full method in here. And this will become x raised to the power of 4 plus 4x squared plus 4 dx. And then integrate. So this will become x raised to the power of 5 over 5 plus 4x cubed over 3 plus 4x. Copy the limits. And then we will evaluate this one. So substitute all the values of x to 2. So this will become 2 raised to the power of 5 over 5 plus 4 times 2 cubed over 3 plus 4 times 2 minus this again and substitute all the values of x to negative 3. Raised to the power of 5 over 5 plus 4 times negative 3 raised to the power of 3 over 3 plus 4 times negative 3. So let's just solve this one. This will become 32 over 5 plus this will become 32 also over 3 plus 4 times 2, that's 8, minus this will become negative 243 over 5 plus 4 negative 108 over 3 plus minus 4 times negative 3, that's negative 12. Just get the LCD to get the answer. So 96 plus 160 plus 120 minus 729 minus 540 minus 180. Okay, so 96 plus 160 plus 120, that's 376. I forgot the pi, sorry. 376 over 15 minus negative 729 minus 540 minus 180, that's negative 1449 over 15. So by using the rule of subtracting integers, change the sign of the subtrahend, then proceed to addition. So change the sign of the subtrahend and proceed to addition. So this will become 376 plus 1449 over 15, and we will get 1825 over 15. So let us simplify. Divide both numerator and denominator by 5. 1 into 5 over 15 divided by 5. It's equals to 365 over 3. So our calculated volume is equal to 365 over 3 pi cubic units. So this is now our final answer.
The second method is called washer method. Washer method used when the axis of revolution is not a boundary of the plane region and the cross-section are taken perpendicular to the axis of revolution. You use the washer method to find the volume of the solid. Think of a washer as a disc with a hole in it, or a disc with a disc removed from its center. If capital R is the radius of the outer disc and small r is the radius of the inner disc, then the area of the washer is equal to pi r squared minus pi r squared, and its volume would be its area times its thickness. As noted in the discussion of the disc, if a washer is perpendicular to the x-axis, then the inner and outer radii should be expressed as a function of x. If a washer is perpendicular to the y-axis, then the radii should be expressed as function of y. So the formula is in using the washer method. There are two types of formula for function if the function is f of y or f of x. So the first formula for the volume of the solid generated by revolving the region bounded by y equals to f of x and y equals g of x on the interval a and b, where f of x is greater than or equal to g of x about the x-axis. So the formula of it is volume equals to integral a to b pi times quantity of f of x squared minus g of x squared dx, when the region bounded by x equals to f of y and x is equal to g of y on a and b, where the f of y is greater than or equal to g of y is revolved about the y-axis, then its volume is equals to integral a to b pi times quantity of f of y squared minus g of y squared dy. Note again that f of x and g of x and f of y and g of y represent the outer and inner radii of the washers, or the distance between a point on each curve to the axis of revolution. So example number 2 for the washer method. Find the volume of the solid generated by revolving the region bounded by y equals to x squared plus 4 and y equals to x plus 6 about the x-axis. Since we're given two functions, which is the y equals to x squared plus 4 and y equals to x plus 6, then we must equate these two functions. So first, x squared plus 4 equals to x plus 6. Then transpose x plus 6 to the left side. So x squared plus 4 minus x minus 6 equals to 0. So we must cancel out the or subtract the similarities. So x squared minus x minus 2 equals to 0. So this function can be factored out. So x plus 1 equals, then x minus 2 equals to 0. So we can conclude that the value of x is x equals to -1 and x equals to 2. Then we can graph it in Cartesian plane or coordinate it in Cartesian plane. So the graph of it will be this. Since there is a linear function, so this straight line, which is the function y equals to x plus 6, then the function y equals to x squared plus 4 is parabola. Y equals to x squared plus 4. Since our since this is the inner radius or radius of inner disk, then this linear function will be the outer or radius of outer disk. So the graph will be this in solving the example number 2, and we can conclude that it can be intersect at the coordinate -1 and 5 and 2 and 8 with the x plus 6 is greater than or equal to x squared plus 4 on interval -1 to 2, as we can see in the graph. Since the formula of Washer method, a to 2b pi times f of x squared minus g of x squared d of x. Since our problem in number 2 focuses on x axis, then we use dx. So we substitute, since our a is equals to -1 and b is equals to 2, and our f of x is equals to x plus 6, and g of x is the x squared plus 4. So we substitute it all in the formula of Washer method. So a is equals to -1 and b equals to pi, and substitute the value of f of x, pi times x plus 6 squared minus x squared plus 4 squared dx. Then we simplify it. So it will be -1 to 2 pi times x squared plus 12x plus 36 minus x raised to power 4 plus 8x squared plus 6 16 dx. Then we further it, we subtract the square root of 2 function. It will be negative x raised to power 4 minus 7x squared plus 12x plus 20 dx. Since we subtract the square root of 2 function, we derive it. So it will be pi equals to open bracket minus or negative x raised to power 5 over 5 minus 7x cubed minus over 3 minus 6x squared plus 20x. Then 2 and -1, which is the interval of the graph or the problem. Then we further simplify it. It will be pi -2, since we apply the interval. So first we apply the interval 2, then afterward minus the interval -1 in substituting the value of x. So 2 raised to power 5 over 5 minus 7 times 2 raised to power 3 over 3 minus 6 times 2 raised to power 2 plus 20 times 2. Then close bracket. Then afterward minus the interval -1 in substituting the value of x. So it will be -1 raised to power 5 over 5 minus 7 times -1 raised to power of 3 over 3 minus 6 times -1 raised to power of 2 plus 20 times 1, -1. So it will be this. Then furthermore simplify it. So we compute the common denominator. So the common denominator of this 15. So it will be this. Negative 96 since we compute this first fraction, 96 minus 280 minus 360 plus 600 over 15. Then afterwards, this is the same as the common denominator of 15. So 3 plus 35 minus 90 minus 300 over 15. So we subtract and add in the inside of the bracket. So it will be negative 136 over 15 minus negative 352 over 15. Then the volume of it is equals to 216 over 15 pi. So the volume of solid of revolution of the example number 2 is equals to 216 over 15 pi. The last method, which is the cylindrical shell method. Cylindrical shell method used when the cross-section of the solid are taken parallel to the axis of revolution. Then the cylindrical shell method will be used to find the volume of the solid. If the cylindrical shell has a radius r and a height h, then its volume would be 2 pi rh, or 2 times pi times r times h, or 2 times pi times radius times height times its thickness. Think of the first part of the product, 2 pi rh, as the area of the rectangle formed by cutting the shell perpendicular to its radius and laying it out flat. If the axis of revolution is vertical, then the radius and height should be expressed in terms of x. However, the axis of revolution is horizontal, then the radius and height should be expressed in terms of y. The volume of solid generated by revolving the region bounded by y equals to f of x and the x-axis on the interval a and b, where f of x is greater than or equal to 0 about the y-axis. Then the formula is equals to volume equals to integral a to b 2 times pi times x times f of x dx. When the region bounded by x equals to f of y, then the y-axis on the interval a and b, where f of y is greater than or equal to 0, is revolved about the x-axis. Then its volume is equals to volume equals to integral a to b 2 times pi times y times f of y dy. So example number 3 in related to cylindrical shell method, which is find the volume of the region bounded by the curves y equals x squared and y equals 0 and x equals 3 is rotated about the y-axis.
For today's video, we are going to talk about cylindrical shell method on solving the volume of solid revolution. So let's start. So before we start, let's draw a picture so that we can easily picture out the whole situation. So first, let's draw the y-axis and the x-axis. Now we are going to find the volume when it is rotated by y-axis. So it is y-axis, x-axis. So now, next is we have to go into draw a triangle. And the limits of integration, so let's just put it as A and B. So the radius is from the x-axis to the axis of rotation. And never forget to look for the height. So this would be the height of the shell. So remember, using the shell method, so we have a formula. So this will be the formula. The volume is equals to 2 pi integration A to B radius in terms of x, and we have the height also in terms of x dx. So that would be for it when it rotated to the y-axis. But what if it rotates to the x-axis? So that would be like this. So it's for, again, picture out. So exploring the rectangle, and let's start with its height, and this would be its radius. So next is the limit of integration. So the limit of integration is we have here the A and the B. Sorry for that. So its formula will be like this. Volume, so again, so volume is equals to 2 pi integration A to B. So the only difference they have is that the radius, it should be in terms of y, and the height should also be in terms of y dy. So now let's have an example. So example number 1, find the volume of the region bounded by the curves y is equals x squared, y is equals 0, and x equals 3 is rotated about the y-axis. So now let's graph it. So it will be like this. So the y is equal x squared is here. And the y is equals to 0 is here, and we have the x equals to 3, so let's just say it's here. Okay, so this would be the shell. Now let's find, so this would be the height in terms of x, and the radius in terms of x. So now let's proceed. So volume is equals to 2 pi integration. So we have a to b, so we have 0 to, so 0 to, okay, so let us just put it as a is equal to 0 and x is equal, so 0 to 3 is equal to 3, so it is 0 to 3 and r the x, the height in terms of x dx. So now let's substitute. So we have volume is equal to 2 pi 0 to 3. So our radius is x and our height is h of x dx. And the next one is volume. So volume is equal to 2 pi integration 0 to 3. So x, so remember that our h of x is this, our height, so it will be x squared dx. So next is volume is equal to 2 pi, so x times x is x cubed 0 3. So ano nga bang integral? No? So what's the integral of x cubed? So 2 pi to x over 4. So na left out tayo sa v is equal to 2 pi x to the power 4 over 4 integration 0 to 3. So next na gagawin is v is equals to 2 pi times, so it would be like this, so x to the power of 4. So remember that our x is equals to 3, x equals to 3, so x equals to 3 to the power of 4 over 4 minus, so since our a is equals to 0, so minus 0, because you can't multiply anything with this, so the answer is still 0, so 0 to 3. So v is equals to 2 pi, so 3 to the power of 4 is equals to, so that would be 81 over 4. So now we multiply 2 by 81, so v is equals to 162 over 4 pi. So 162 over 4 is equal to 40 and 1/2 cubic units. That will be the answer. That will be the volume.